Assalamu alaikum. Today we will start with part 6 of our lesson Algebraic Expressions. Objectives: at the end of this video you will be able to factorize an algebraic expression using remarkable identities, factorize polynomials. Materials: please prepare a paper, a pencil, a calculator, and your textbook. Factoring polynomials. How to factorize polynomial by using remarkable identities. Sometimes we cannot factor polynomial using the common factor property as usual, so in many cases we may use remarkable identity that can help. We know that the expanded form of the first remarkable identity is a trinomial having all its terms positive, while the factored form is a perfect squared. The expanded form of the second remarkable identity is also a trinomial having one term negative and its right side is a perfect squared, which is a minus b squared, the factored form. The third remarkable identity, a squared minus b squared, has its expanded form a difference of squares, a squared minus b squared, while its factored form is a product of a plus b times a minus b. Example, let us factorize x squared plus 6x plus 9. First, we look for two squared terms, two perfect squares. Here, x squared is a perfect square, and 9, which is equal to 3 squared, is also a perfect square. 2. We identify the identity to be used. Here we have three unlike terms, so we have a trinomial. This trinomial have all its terms positive, so we should use the first remarkable identity, which says that a squared plus 2ab plus b squared equals a plus b squared. Solution. Here we will compare the coefficients. We will get x squared is equal to a squared plus 6x plus 9. We compare the first term and the last term. X squared is equal to a squared. This means that a equal x. 9 is equal to b squared. This means that b equals 3. Now we get the value of a, which is x, and the value of b, which is 3. 2ab equals 2 times x times 3. We use this to check if the answer is true or not. The answer is 6x, which is true. So we will use first remarkable identity to get x squared plus 6x plus 9 equal x squared plus 2 times x times 3 plus 3 squared. Since x squared equals to a squared, 2x3 equals to ab plus b squared equals 3 squared, we will apply the first remarkable identity to get the perfect squared x plus 3 squared. Factoring using remarkable identities, square of a sum, a squared plus 2ab plus b squared. Application: use identity to factorize 1. 49y squared plus 14y plus 1. 2. m squared plus 12m plus 36. Please pause this video and try to do it by yourself. Solution: 49y squared plus 14y plus 1. Clearly we have a trinomial. First of all, let us search for the two terms that are perfect squares. The first one is 49y squared because 49 is a number that can be written as a perfect square since 49 equals 7 squared. So we get that 49y squared equals 7y squared. The other term is 1, which is a perfect squared already. 1 squares equal 1. Now we get that a squared is 7y squared, so a is equal to 7y, and b squared is 1 squared, so b is equal to 1. So 2ab is 2 times 7y times 1, which is 14y. Now we can apply first remarkable identity directly. The answer is a perfect square, a square of a sum, which is 7y plus 1 squared, a plus b squared. Similarly, m squared plus 12m plus 36, the two square terms are m squared and 36. M squared is equal to a squared, and 36 is a perfect squared, which is equal to 6 squared. So a is m and b is 6. For 2ab we have 2 times m times 6 equals 12m. So we can apply the first remarkable identity also. The answer is m plus 6 squared as a plus b squared. Factoring using remarkable identities. Example: factorize 4x squared minus 20x plus 25. First, we look for the squares 4x squared and 25. So we may use remarkable identity. 2. We identify the identity we may use. Here we have 3 unlike terms in the expression, which is a trinomial. Third, we have one negative sign, so we will use the remarkable identity number 2, a squared minus 2ab plus b squared equals a minus b squared. Solution: we will compare the coefficients to get 4x squared minus 20x plus 25. 4x squared is a squared, so a squared equal 4x squared equal 2x squared, since 4 equal 2 squared, so a equal to x. B squared equal 25, so b equals 5. 2ab equals 20x, which is true. Then we apply the remarkable identity directly to get 4x squared minus 20x plus 25 equal 2x squared, which is a squared, minus 2 times 2x times 5, which is 2ab, plus 5 squared, which is b squared. The final answer is 2x minus 5 squared as a minus b squared. Factoring using remarkable identities. Square of difference: a squared minus 2ab plus b squared. Application: use the identities to factorize the following. Please pause the video and try it by yourself. Solution: 25y squared minus 30y plus 9. First of all, we look for the squares. Here we have 25y squared and 9. So a squared is 5y squared, a equal 5y. B squared is 3 squared, so b equals 3. And 2ab is 2 times 5y times 3, which is equal to 30y. Now we apply remarkable identity to get 5y minus 3 squared, which is a minus b squared. 9m squared minus 6mn plus n squared. Similarly, 9m squared represents a squared, so a equal 3m. N squared represents b squared, so b equal n. 2ab is 2 times 3m times n, which is 6mn. So we apply the remarkable identity number 2, 3m minus n squared. Factoring by using remarkable identities. Example: factorize x squared minus 4. Here we look for the two squares that are x squared and 4. So we may use remarkable identity. 2. We identify the identity to be used. There are two unlike terms in the expression. This is a binomial. We have a negative sign between the two terms, so we will use the identity a squared minus b squared equals a plus b times a minus b. Solution: we will compare the coefficients. Here we have the first square term is x squared, so it will be equal to a squared. The second square term is 4, which is 2 squared. So a squared equals x squared, then a equals x. B squared equals 4, so b equals 2. Now we get x squared minus 4 equals x squared minus 2 squared, where a is x and b is 2. As the remarkable identity says that a squared minus b squared equals a plus b times a minus b, so the answer will be x minus 2 times x plus 2. Factoring using remarkable identities, difference of squares a squared minus b squared. Application: factorize the following expressions by using remarkable identity. Please pause the video and do it by yourself. Solution: for part 1 we have 16x squared minus 9, which is a binomial. 16x squared, since 16 can be written as 4 squared, so 16x squared equal 4x squared, which is a squared, so 4x is a. 9 can be written as 3 squared, so 9, which is 3 squared, equals b squared, and 3 equals b. Now we have a difference of squares, a squared minus b squared, so the answer by using the third identity is a minus b times a plus b, where a is 4x and b is 3. 4 times x minus 1 squared minus 2x plus 3 squared. First of all, we have a square minus a square. But we should pay attention that 4 times x minus 1 squared is not a perfect square, since 4 is not written as a square. But we already know that 4 is equal to 2 squared, so we can write it like 2 times x minus 1 squared. Now it is a perfect square. Now we have a square minus a square, a difference of squares. Here, let us identify the term a and the term b. Here, the term a squared equal 4x minus 1 squared. Then a is 2 times x minus 1. The term b squared equal 2x plus 3 squared. So the term b is 2x plus 3. Now we will apply third remarkable identity, which is a squared minus b squared equal a minus b times a plus b. A is 2x minus 1 minus b, which is 2x plus 3, multiplied by a, which is 2x minus 1, plus b, which is 2x plus 3. Now we will reduce the expression as we did many times before. We get minus 5 times 4x plus 1. Application: factorize x squared plus 18x plus 81 minus x plus 9 times 2x minus 5. Please pause the video and try to do it by yourself. Solution: please note that the first part of this expression is a trinomial having all its signs positive, so we may use first remarkable identity. Here, a squared equals x squared, then a equals x, b squared equals 81, so b equals 9, and 2ab equals 2 times x times 9, which is equal to 18x, which is true. Now we apply remarkable identity to get x squared plus 18x plus 81 equal x plus 9 squared. Here we have the expression. After doing the first remarkable identity, we will note that we have a common factor, which is x plus 9. Now we put x plus 9 aside. We know that x plus 9 squared is the multiplication of x plus 9 by itself. So when we divide x plus 9 squared by x plus 9, we get x plus 9 inside the brackets minus x plus 9 times 2x minus 5. We get 2x minus 5 inside the brackets. Finally, we reduce this polynomial as usual to get the final answer, x plus 9 times minus x plus 14. Assignment: please review from your book the following page. Homework: please do the following homework from your textbook. Summary: please read the summary carefully and take notes to your copybook. Thank you very much.